Now we are going to learn about what is the terms of memory map. Okay, so we have the memory here and we have the map. So in Bahasa, it's just like you want to map your memory. Okay, you want to map your memory. So what is the memory located? What is the real memory over here? So if you want to look at the board, the complete board of 68K, so this is the one. Alright. So you have these particular things on the 68K over here, and you also have the RAM. Remember that the registers is inside this CPU, the registers, and the RAM is outside from the CPU. So this is the complete ports. Okay, memory map is related to this particular RAM. This is the RAM. So you have to know that how the map how the maps looks like and how we are going to draw the maps. Okay, like before this, that we have learned that based on 68K, the address pin is only at 24 pins. So the maximum address for the RAM should be 2 to the power 24 minus 1, which is started from 0000000 to dollar sign F F F F. Okay, so what is actually really a memory map? So a memory map is a structure of data that indicates how the memory is laid out. So you have the memory, so you want to lay out your memory. How in the class that we are going to do, normally we have the memory map to be draw like this. So we have the sorry here. So we have the memory map like this. For example, you have two locations like this. So you're going to start like this. This is the first one where you are going to put this one as a number, dollar sign 0000000. So this is the location of that, and the next one is 0000001, and it will be continuous over here, dollar sign 0000002, and so on. At the end of the final one here, this one will be dollar sign FF. So this is the last one. So the way that we draw our memory is like this. So over here on this side, this is they call it an even address, where you can see that this is all even address over here, and over here we have the odd address like this. So you can see that this is all odd address. So why is this important? Because you need to know that you can draw the memory here. This is the physical memory, so we want to map it like, and we want to let it out as an image for us to understand that. So we have to draw like this. So you have two like this, then you have the address. Differently from easy 68K, the memory is like this. Let's try move top down, dollar sign AA, close, dollar sign, move top down, move top back. Symbol, undefined symbol. Oh, sorry, this one. You have to remove this one. But in easy 68K, we don't see this kind of memory map drawings, but we are looking at this type of memory where it is actually the same, But the thing is, you need to understand how sorry, how it works. So this is a memory. So I'm going to have this one to be compared. So you have this kind of drawings, and we also have another drawings over here. Let's try. So we have your memory. This is the address, and this is its odd, its even address, and then its source address, because this is a continuous number. So you can draw, which is the same one like this, because it's, you can see differently, but the thing is it represents the same thing. Okay, why is this important? Because normally when you draw like this, you know that there are locations has been reserved. For example, this, right, you can see that for example, this area is reserved for your input output, for example. So how we want to know that this one is reserved? For example, in our simulator, you can see that from here, if you run this one, the hardware, so you can see that this is the address, which means that this is the address mapped to the memory. So this input output is actually mapped to your memory. So what does it mean is this address, this LED, this 7 segment address is mapped to your memory over here. For example, for the case of E0000, which is over here, possibly maybe around here is E000000 is reserved for the 7 segment. And for the case of E000010, possibly maybe here, E000010 is reserved over here. So this is your LED. So this is reserved for LED. Okay, so this is maybe reserved for the 7 segment. So you can see that from your simulator, we have another windows over here, sections that to show that you have the close this one first. You have the, let me close this one, hardware, where this is all hardware input output is mapped to your memory. So you need to understand, so the terms of memory map is to map your memory as like this. Okay, so for example here, if your LED is mapped to here, so actually you can send data to the memory here, and you can turn on your LED. For example here, these locations is a 8-bit, right? 1 2 3 4 5 6 7. So let's try here. So this address is 1 2 3 4 5 6 7 8. So each of the memory have 8-bit of size. So right now the location is E00010. So you can write something to the software like this. Again, move.byte hash $f0 to this location. Remember that this location is mapped to the LED just now. So what is the data for the F0? F0 means what? F0, if you convert to binary, this is going to be 1 1 1 1, and this is going to be 0 0 0 0. So what happened if you move this data to this location, which is mapped to your input output as the LD? the LED is the output. So we run it, this one. You go to your view on the memory, go directly to E00010, and also you can also view the hardware. So E00010 is this one. I have not yet run this one. So let's put this value to this location, which is this location mapped to your LED. Okay, let's run it. You can see that this location is F0, and then you can see also that the LED, the first 4 bit is turned on and the last 4 bit is turned off. It's because of this one. Just now you have F, you turn on, you give 5 volts, for example, you give signal 111, so all of the first 4 LED is turned on and the rest is turned off. So let's try another example. Maybe you want to turn off the lower 4, so you can put the data as 0F. This is all 0000 and this is all 111. So let's try. Instead of F0, you change it to 0F. Then go to this particular memory location and then you execute it. Look again, still nothing yet. I haven't executed this one, so run this one. You can see that this is 0F and this is 0 and this is F. So you can turn on different LED accordingly on the binary representation just now. So if you want to turn on only few of them, for example here, if you want to turn on only LED, 2 LEDs only, like or maybe 4, but maybe for the Hari Raya or whatever hari that you want to turn on like this, you want to turn on. So you can divide this one. This is equivalent to 8 plus, sorry, this is 1 2 4, this is 5, this is 4 plus 1, this is also 4 plus 1, which is equivalent to 5. So 5 in decimal is equivalent to 5 in hexa. So let's try to put 5 5. Instead of 0F, we try to put 5 5. Run it, execute it, and run. So you can see that this is turn off, turn on, turn off, turn on. So the memory is the location that where you want to map your input output. So for the case of this simulator, you have the hardware over here, which is all your input output already have its own address, and this address is mapped to the memory, and this memory is the one that communicate with your CPU. So your CPU is going to send the data to the memory, and the memory is mapped to your input output. So this is how it works. Okay, to recap, what you learned for this video is the big term about memory map. Okay, thank you very much.